Welcome to TechOps Tribe, brought to you by Automation. Today, we're going to pull back the curtain on one of the most fundamental yet misunderstood parts of the internet, the IP address. Now, I know it sounds super technical, but I promise you, by the end of this, you'll see it's really as simple as a digital mailing address.
Seriously, have you ever stopped to think about that? You type a website into your browser, hit enter, and poof, it appears. How in the world does that website know to send its data back to your specific phone or laptop and not, the one your neighbor is using right next door? That little bit of magic is exactly what we're unpacking today.
All right, so let's get right to it. At its heart, an IP address, which stands for Internet Protocol Address, is basically the internet's version of a postal address. Simple as that. Just like a package needs a street, a city, and a zip code to get to your front door, any piece of data flying across the internet needs an IP address to find its correct destination. It's the essential coordinate for literally every single thing you do online.
But here's where it gets really interesting. You don't just have one single digital address. Nope. You're actually juggling two main types every single day, and you probably don't even realize it. So let's break down the difference between your address for the outside world and the addresses used inside your own home.
This is where that mailing address analogy really clicks. Your public IP? That's like the main street address for your entire house. It's the one address your internet provider assigns you. And it's how the whole world, we're talking Google, Netflix, you name it, finds your network. But inside your house, right, you've got your laptop, your phone, a smart TV. Your router gives each of those a private IP. Think of them like room numbers. That way, your router knows to send that movie stream to the living room TV and not to your printer.
So here's the key takeaway. Your router is basically the superstar mail sorter of your digital home. It uses that one single public IP to chat with the rest of the internet, but then it uses all those little private IPs to play traffic cop internally, making sure the right information gets to the right device. It's an incredibly smart and efficient system.
Okay, so on top of being either public or private, there's actually another layer to this. IP addresses can also be either permanent or temporary. This is all about whether your digital address is set in stone or if it changes from time to time.
A static IP is like having a permanent PO box. It's yours. It never changes. This is absolutely critical for something like a business website because you need your customers to find you at the exact same address every single time. Now, on the other hand, most of us at home, we have a dynamic IP. You can think of this one like a temporary hotel room number. Your internet provider assigns you one for your session, and next time you connect, you might get a different one.
So why the split? Well, it all boils down to two things: reliability and efficiency. Businesses will often pay extra for the rock-solid reliability of a static address. For the rest of us, dynamic addresses are just way more efficient. It lets internet providers recycle and reuse addresses from a limited pool, which is a much smarter way to manage a network for millions and millions of customers. And, speaking of a limited supply, that became a huge problem. See, the original system for IP addresses was designed way back in the early days of the internet. The inventors were brilliant, but they never in a million years imagined a world where billions of people would each have a phone, a laptop, a watch, a TV, all connected at once. That original system is called IPv4. It uses that format you've probably seen before, 4 sets of numbers separated by dots. And for decades, this 32-bit structure was the gold standard. And it gave us about 4.3 billion unique addresses. Back in the 1980s, that felt like an infinite number. But today, with a global population of 8 billion people, most of whom have multiple devices, well, you can see the problem. We were running out of digital real estate fast. The solution was a massive system-wide upgrade called IPv6. It expands the address space from 32 bits all the way to 128 bits. Now, this wasn't just a small step up. It was an absolutely colossal leap, designed to make sure we'll never, ever, ever run out of addresses again.
So how big of a leap are we talking about? The number of possible IPv6 addresses is 340 undecillion. I mean, that's a number so mind-bogglingly huge, it's almost funny. It's enough to give every single grain of sand on planet Earth its own unique IP address and still have trillions upon trillions left over. Yeah, I think it's safe to say the shortage problem is solved.
All right, so besides the main types we've talked about, there are also a few specialized IP addresses that act like a special delivery service, each one designed for a very specific job. First up, there's the loopback address. It's like writing a letter and mailing it to yourself. It always points right back to your own computer, which is super useful for developers who need to test things. Then you've got multicast.
This is like sending a party invitation, but only to a specific group of friends. It's the secret sauce behind live streaming a concert or a big game to thousands of people at once. And finally, there's broadcast, which is pretty much like shouting an announcement to everyone in the room. It sends a message to every single device on your local network.
Okay, so we've covered public and private, static and dynamic, and even some of the special cases. Let's put all these pieces together and look at a few quick examples of how this stuff actually works in your day-to-day life. When you fire up your laptop and connect to your home Wi-Fi, your router gets a public, dynamic IP from your internet provider. This is, hands down, the most common setup for home internet on the planet. Now think about an office printer. That's a perfect use case for a private static IP. It's private because it's only for people inside the office network, and you want it to be static so everyone's computer always knows exactly where to find it without having to ask for directions every time they need to print.
What about the website you're looking at right now? Well, it lives on a server that has a public static IP. It has to be public so anyone anywhere in the world can get to it, and it absolutely must be static so that its address never changes. That way, the domain name always points to the right place.
And finally, that huge live sports event you're streaming this weekend, that's using multicast addressing. It allows the broadcaster to send a single, powerful stream of data that gets delivered to all the thousands of viewers at the same time. It's way more efficient than trying to send out thousands of individual streams.
So when you boil it all down, it really comes back to this. Every single thing that connects to the internet, from your phone in your pocket to a massive web server in a data center, has to have a digital address. This system is the invisible foundation, the tireless postal service of the digital world that makes all of our online communication possible.
So now you know exactly how your digital address guides the internet right to your screen. But that brings up a much bigger, more interesting question, doesn't it? If this address is a signpost pointing directly to you, what other little breadcrumbs of information might it be revealing about you along the way? Something to chew on the next time you connect.